Well, welcome to this presentation. Thanks for coming. Thanks for having me here. Hopefully there'll be something useful that you can get out of this. I don't know. We'll see. A little bit about me. My name is John Turner. I work at a company called Job Nimbus. We're just kind of across the freeway. I just started there last month, actually. Today, I think, is my 1 month anniversary. So yay for me. I have some contact information on there. The one, most of it's pretty standard stuff. The one that might be a little interesting is I run a meetup group called Utah Software Craftsmanship Group. There we talk about things like test-driven development and paired mob programming and continuous integration and continuous delivery and stuff like that. So if you want a group of people to talk about that kind of stuff with, that might be interesting for you. I have a QR code here that goes to the slides. If you want to scan it and follow along at home, that's feel free. If you don't want to commit to actually lifting up your phone and scanning it yet, I'll put it at the end too. So if you want to wait and reserve judgment, that's okay too. Okay, so first I want to talk about who is this presentation for? Who's my target audience? I like to think about it in terms of the technology adoption curve. Maybe you have seen this before. You have the innovators over on the left and the early adopters and early majority and so on until you get to the laggards over on the right. This is typically how technology is adopted. It's adopted by a very small number of people initially, and then you grow to this big critical mass, and then you have this long tail of people who take longer to adopt that technology. So I like to think that this presentation is geared towards this big middle section here, the big bump in the middle there. Maybe into early adopters a little bit. I feel like we're kind of still in the early adopter phase for a lot of these AI tools. They're changing a lot and everything. So I feel like we're kind of over here. If you're really in the early adopter phase or in this innovator phase over here, if you're obsessing continually about which model is the best one for which practice, which part of your process, or your every day you're running out of your token allotment, maybe you'll get something out of this, but it's probably not geared. This might be a little slower than what you're looking for. Also, if you're over here in the you can put AI tools in my cold dead hands group, my goal is not to convince people who are adamantly opposed to it or anything like that. So if you're in that category, this might not be this presentation may not speak to you personally. So given that, anyway, what are we going to talk about? The subtitle, I guess, of this presentation is, what is it? A skeptical craftsman's guide of AI dev tools, something like that. I don't know. So I'm coming at these from the perspective of this software craftsmanship sort of viewpoint, right? So I want to kind of start by talking about a little bit of what that means to me, some of the things from that viewpoint of software development that I have found valuable for me, and then go on to talk about some ways that I have used some of these AI dev tools, and a little bit about how that translates into that viewpoint. And then at the end, we're going to do more how these two things combine, and what can we learn from them, right? And some takeaways. So if that sounds interesting, you're in the right spot. If not, feel free to put your head down. Take a nap for a little bit. You probably deserve it. Okay, so the first thing I want to talk about, as a software craftsman, what are some things that I value? So you kind of get my software craftsman perspective as we go into talking about these AI tools. First of all, though, I want a disclaimer. Actually, I have two disclaimers at this point. One is that I'm getting over a cold, so if I go into a coughing fit, I apologize in advance. But my actual disclaimer is I'm using the word craftsman and craftsmanship. Some people have a hard time with that word because they feel that it's exclusionary. That's not my intent. My intent is not to exclude people with that term. I just haven't figured out a better term that conveys the like experienced and aspect of the term and the focus on quality and how we actually do the things that we do. There are some other terms that are kind of close. Like some people use the term artisan, like a software artisan, but that to me feels a little bit more focused on the aesthetic part of things than on the functional part of things. I think Craftsman, to me at least, anyway, speaks a little more to the like functional part of it. Some people use the term software crafter, which isn't terrible, but I grew up with parents who owned a craft store. So to me, the word crafter means like googly eyes and pom-poms and stuff. So like to me, the term crafter like misses that mark a little bit. So anyway, in my usage of the term craftsman and craftsmanship, I don't mean to be exclusionary in any way. That's just the best word that I have so far. So if you have a better word that you feel like means the same thing, let's talk about it afterwards. But okay, so the first thing I want to talk about is that I have found valuable from a software craftsmanship perspective is delivering value frequently. Now, I don't know about you, occasionally I will write code and I just do it for the fun of problem solving or to learn a new skill or to practice something. But most of the time when I'm writing code, I get the most fulfillment out of it when one or more people actually use it. They use it and they find value in it. That's when coding is usually the most fulfilling for me. It's a thing that I've come to value. Like I like it when I can write code that people use and it helps them their day be better somehow. It helps them do their job or move money around or it's just a cool thing that makes them laugh or whatever. I get some kind of value out of it. And I like doing that frequently because I like dopamine hits. And so if I have to wait too long between delivering that value and getting that dopamine hit, I don't like that. I like to do it frequently, right? If I'm going to be delivering value frequently, I'm going to need to be changing my code frequently. So I'm going to need to be maintaining my code and adding features to it or changing functionality, whatever. If I have code that's hard to do, then I'm not going to be able to deliver value frequently. It's going to be infrequent, and I'm not going to get the dopamine hits that I want, right? So I want my code to be easy to change. That's a thing that I value because that's kind of the whole point of having it be software rather than hardware, right? That's where the term software came from because it's supposed to be easy to change. I think over the years we kind of lost that. Kind of forgot about that. But anyway, one of the ways that I found to best develop maintainable code that I can change easily and frequently is through test-driven development. And by test-driven development, I mean actual like driving the design of my code via the tests that I write, as opposed to just I'm going to write some code and I'm going to write some other code that tests it, right? I want to actually drive the design of my code via my tests. So the whole red-green refactor cycle, I found a lot of value in that. I found that when I do test-driven development, it tends to result in simpler, more maintainable code. So that's the thing that I valued. I've come to value a lot collaboration. Often when I'm in a programming, writing code activity, this takes the form of pair or mob programming. Some of the best, most valuable, most maintainable code that I've written has been written when I was pairing with someone or mobbing with a group or something like that. This doesn't have to be exclusively like software engineer to software engineer collaboration. It could be, more cross-functional than that as well. But those are common examples like pair programming and mob programming, right? That's the thing that they value. And in general, feedback loops, like test-driven development is a great example of a feedback loop. You get really fast feedback on did this change that I make, did it make my code better or worse? Did I break everything or does everything still work? You get really fast feedback loops. You also get really fast feedback loops on that design because you're testing you're testing your design as you're writing tests for your code, right? So you get functionality feedback really fast, design feedback really fast. There are other types of feedback loops. Some common examples are like continuous integration, continuous delivery. If I can integrate my changes with other people's changes frequently, I can get feedback about whether or not my changes work. If I deploy frequently, I can get feedback about how my code will behave in production, right? Ideally, I will get feedback from my customers in some way when I do that, about does this software actually deliver value? Does it work? Does it crash, for everybody? So these various kinds of feedback loops are a thing that I found very valuable for me. Okay, so those are some of the things from this like software craftsmanship perspective that I have come to value over my experience in software development. So when I think about these AI dev tools, I try to think about them from the perspective of not like, are they good or bad, or are they going to steal my job or not? Or I try to look at them from the perspective of, do they help me do these things that I value better? Do they improve those things or do they make them worse, right? And so with some of the things, well, we'll talk about that a little bit more at the end. Okay, so that's kind of the perspective that I look at them from. So I wanted to talk about some examples of some ways that I have worked with AI dev tools over the last, I don't know, a few months or something. One of the things, I went to a conference a few months ago, and one of the things that I found kind of challenging is that people were talking about AI things, but they were talking about them in fairly high-level terms, like, oh yeah, I used agents to do this thing. I'm like, okay, well, what do you actually mean? Like, how? Show me the pieces, and like, show me the code, right? So, so one of my intents in talking about some of these experiences that I've had is maybe you've had similar experiences where you've been like, okay, well, I've used it this way, and I've heard of other people using things this other way. What does that actually look like? Hopefully, you get a little bit of that too. Maybe get some other ideas of things you could that maybe you haven't tried. Maybe you've tried all of these, and you're super. This will all be super boring. But maybe there will be some new things, new ideas of ways you could use some of these AI dev tools. Okay. Oh. This is my second disclaimer. This is my second real disclaimer. So there are a lot of AI dev tools. I don't know if anybody's noticed this, but there are a lot. So and my experience by no means covers all of them. So I'm going to share the ones that I do have experience with. But if I missed your favorite tool, then sorry about that. Most of my examples are like ChatGPT, Copilot, and Claude Code. So, all right. So the first one I want to talk about is what I call non-code chat. What I mean by this is like, if you just go to chatgpt.com and start typing something in and having a conversation with it, that's what I mean here. I found this can be valuable. Like I call it non-code because it's not like in a direct code, like not in an IDE or a terminal or something like that. But you can still get, there are a lot of things that I find it valuable for, like ideation. I want to talk through this idea, this feature that I'm building, or this presentation that I want to give, or something like that. How help me generate ideas for it. Like I've found that sort of interaction really good for ideation. It's really good for presentation titles. You want like a presentation title that sounds cool and hits on specific highlights, like software craftsmanship and a skeptical soft craftsman's guide to whatever. Yeah, that AI helped me with that one. In case you couldn't tell. Recently, I've been redoing my resume, and AI was this, like ChatGPT or Claude or whatever, and this chat interface was great for that. That's some things. On a more software development related note, I found it's really good for. I'm going to use the term rubber ducking. Rubber ducking is actually already has a definition, and I'm using it in a slightly different way here. Traditionally, rubber ducking is I'm working on this problem and I encountered a roadblock, so I'm going to go talk to someone and explain my problem to them with the intent of asking for help, but oftentimes just the act of explaining the problem, I find the solution myself. And so like the joke is you can just explain the problem to a rubber duck on your monitor, and verbalizing and explaining the problem, you'll actually find the solution. So you don't need a real person. You can just do it with a rubber duck. When I say rubber ducking here, I mean, I'm using it in a slightly different term. I haven't found a really great term for it. Let me give you an example. So at work, a few months ago, we had this issue where when people would go to our website, 99.99+% of people would get to the right website and the certificates would work and everything like that. But every once in a while, someone would go to our website and they would get a certificate error. They'd get the wrong certificate. And like no one could reproduce it locally. We tried it on different browsers and different devices and different ISPs and all the things that we could think of to try. Nobody could reproduce it consistently. Excuse me. And so I went into ChatGPT and said, okay, ChatGPT, here's the problem that we're facing. Here are the things that we've tried. Here's all the data that we have about it. Help me like reason through this problem and think about what other places where it could be going wrong. Because I knew that it was actually going wrong, but I didn't know exactly where. So it was actually really helpful because it said, oh well, once I got enough context, it said, oh well, it could be, given the information you've given so far, it could be this or this or this. If you want to rule out this one, here's a command you can, here's a dig command you can go run. To rule out this one, here's this other command you could go run. Here, to rule out this one, and then I could go run the commands or whatever. Get more information about the certificates and DNS and all that good stuff. And as I did that, it kind of like slowly narrowed it. It turned out it was DNS because it's always DNS, right? DNS is always wrong. We all know this. It's a law of the universe. But so this isn't quite the same meaning of rubber ducking as the traditional meaning, but I haven't come up with a better term for this. But like this troubleshooting, problem solving sort of interaction mode. It can actually be really good at this. If you haven't tried this, I'd recommend it. However, I call this the non-code chat. I put non-code in quotes because it totally can write code. Like if you go ask ChatGPT to write you some code, it's totally happy to write you code. And so like in this other example, I did that. I wanted to do a code kata that I've done multiple times. This was from a couple of years ago, and I said, hey, write code that converts Arabic numerals to Roman numerals. And of course, ChatGPT just spit it out. It did it in Python. And I was like, I don't like Python. That's not true. I just said I would prefer it in C# because this .NET user group. So it rewrote it in C#, and it was it totally did that. And it can totally do that. And nowadays, like when I did this ChatGPT, it would just like spit code out at you. Now there is a mode where it can like actually go and run the code. At the time, it couldn't run the code at all. It would just spit the code out at you, and you could like copy and paste it somewhere or whatever. But with this kata, I wanted to try and see if I could do a more. So it just spit the code out at me. I wanted to see if I could get it to do in a more iterative approach and actually do test-driven development. So I started again and had to do that. And I was like, okay, write a test, make sure it fails, write the implementation. Okay, great. Make sure that it passes. Do any refactoring we need to. Write another test. And it was actually doing pretty well. I did like the 1 case and 5 and 10 and 2 and 6 and stuff like that. I was doing pretty well. But then I said add a test for 50. And if you're not familiar with Arabic, with Roman numerals, 50 goes to L. 50 is represented by L in Roman numerals. And so I had to write this test, and it did great. And then I said, okay, now go do the implementation for it. And it gave me this code, which I don't know how well you'll be able to see here. And I looked at it and I was confused for a minute because in this code, the term 50 never shows up. The term L never shows up. And so I was like, wait, how are you converting 50 to L if you don't have 50 and you don't have L anywhere? Like I was wondering if it was doing some weird like math thing, and I tried to parse it. And like, how does that actually work? And so I asked it, how does this, do all the, I said, does this code still pass all the tests? And it produced this output and was like, oh yeah, see, this test passed, this test, and it put little green check marks and everything, just like I was used to in my IDE or something. But I couldn't figure out how it passed it, how the tests passed. So I took the code and I took the tests and I went and put them into my actual IDE and I ran them. And lo and behold, the tests did not pass. And so I asked ChatGPT, I said, hey, these tests don't actually pass. Why did you tell me that they passed? And it gave me this answer. I said, hey, you told me you ran all these tests and they passed, but they didn't. Why did you do this? And it said, oh, I can't actually execute code. I rely on logic and theoretical analysis to anticipate how the code would behave. I was assuming that the code would work. So basically, it thought about it really hard and thought it should work. Which, if I wanted that, I would just go and ask any developer off the street, right? Because that's what we all do. Like, we look at the code and we're like, I thought about it really hard and I think it works. Yeah, I don't want my AI tools doing that. Anyway, so that's just something to be aware of. If you can't actually run the code, be wary of it. That's why, like, where we're at. Again, when I did this was a couple years ago. Now we're in a place where it's much easier for AI tools to actually compile code and run tests and things like that and get actual feedback, as opposed to I thought about it really hard and I think it's good, right? But if you're in this kind of setting where you can't actually execute code or execute your tests, be careful of code that it generates. I want to talk a little bit about autocomplete. If you are newer to AI dev tools, this might be a good way to get introduced to them. This is an example in VS Code. So we've probably all seen traditional autocomplete before, where based on your language compiler, you might, when you start typing something, it might autocomplete with things that are syntactically valid in that situation. Or if you're in like a non-typed language, it might just look at all the tokens you have in your current file or something and auto-suggest those. Instead of doing one of those mechanisms to auto-suggest stuff, it will use AI to auto-suggest stuff. And it can actually do some really smart things. Like it can use, in this example, I have I don't know if you can see it with the dark gray on black here, but I have a comment there that says loop over all the tiles and store the names in a list. So I can write a comment, a pseudocode comment like that. And then the AI uses that as part of its context. And so as I start typing, it's like, oh, I think they want to write a for each loop. And so you can see this next line, the one that's highlighted. Maybe you can see it. Anyway, it's suggesting, hey, I think based on your comment, I think you want to do a for each loop in here. Let me type it all for you. Right? So that's kind of cool. Sometimes that can be great. Sometimes it can be horrible. So, beware. But if you don't feel comfortable like jumping super into AI stuff, this can be a good like introduction to it. I want to spend most of the rest of my examples talking about agent mode. So this is what some form of agent mode is what is probably the most popular way to interact with AI dev tools right now. So I say agent mode. There are oftentimes, depending on the tool, there are oftentimes multiple agent modes. Some tools let you do your own like custom agents and stuff like that. A classic example of this is a screenshot from Claude Code. It is specifically in planning mode. Here, some AI tools will let you explicitly switch between these different modes. Sometimes they will implicitly do it and try to figure it out. It used to be in Copilot that it had had a drop down for which mode you wanted to be in. You could have it be, you could have Copilot be in ask mode, where you just ask it questions about your code, and we'll go look at stuff and like come back with answers. But it doesn't edit it or anything like that. It had an edit mode where you could say, "Hey, go make this change for me," and it was fairly limited in scope to like just files that you had open. There's in Copilot there used to be a separate plan mode. In Claude Code, there is still a separate plan mode where you can say, "Hey, I want you to go do this thing, but don't do it yet. Come up with the plan for it. Come up with what you would do." It's sort of like a dry run almost, but then it'll show you the plan, and then you can look at the plan and say, "Oh yeah, I like that you were going to do this. Oh no, don't delete the production database. That seems like a terrible plan. Let's not do that." Then you can adjust the plan before it actually executes it. In like Copilot, you don't have a drop down to explicitly choose the mode. Now it just sort of like infers what you want to do. So you can say, "Hey, tell me about this code, don't change anything," and it would implicitly go into that ask mode. Usually in this mode, like I'm just going to do, but if you asked it to edit something, then it would do that. If you asked it to, "Hey, come up with a plan for how you would do this," it would go into plan mode, right? Usually in this sort of mode, both for Copilot and Claude Code, it will ask you for permission a lot. Like if it wants to go look at files, it will ask you for permission. If you goes to edit files, it will ask you for permission. And that gets really annoying for people because you have to keep saying, "Yes, do this. Yes, do this." And so now, like in Claude Code, I don't know, a couple weeks ago, they introduced auto mode, which is not as terrible. Well, we'll get to that in a minute. It doesn't ask you for most of the things that it thinks are safe to do, like, "Hey, I want to list the files in this directory," or "I want to go read this file that is in a directory that you already gave me permission for." Like it doesn't ask for a lot of those things. But things that it thinks are more dangerous, it will ask you for. And then there's the do stuff but don't ever ask. This is awesome. If you go in Claude, there's a mode. If you get all the command line options for Claude Code, there's this one right here, which if you can't see it from the back, yes, it is called dangerously skip permissions. That's the best command line argument name ever. So yeah, in this mode, it just does whatever it thinks it wants to do, and it disables all things, all the like permissions. Like it won't ever ask you for anything. They did this originally because people got super annoyed with the "yes, do this, yes, do this, yes, do this thing that I've told you to do 4 times." And so they added an option of, "Oh, we'll just always do whatever you think you should do." As you can imagine, that doesn't always turn out super well. So then in Claude Code specifically, they recently, a couple weeks ago, added an auto mode where it tries to be smart about that. That's that middle ground where it doesn't ask you for everything, but it also doesn't automatically do everything. So far, I've really liked that one because it it feels like it's a good mix of just do the stuff that I know that you need to do, but don't do terrible, horrible things that I'm going to regret later. Okay, let's see. Oh, so this is an example of this like agent mode. This is Copilot in Visual Studio Code. You get the little pane over to the right, and you can ask it things and tell it to do stuff like, "Are there any significant tests missing from this set of tests?" And it totally thought there were, but it actually looked at more tests than just the file that I had open, so which wasn't really what I wanted to do. Anyway, so then you can talk to it. This is Claude Code. This is a terminal app. This one's super popular right now. It's the exact same thing, but instead of in your IDE, you can do it at your terminal. If you're scared of terminal apps and stuff, like it's not really, you can just talk to it in natural language for most things, and it like you don't have to remember a bunch of command line arguments and stuff like that. And it'll even do, like if it has if it comes up with a question for you and has wants to give you 3 different options, it will pop up and you can just select which one you want or edit them and stuff like that. So like if calling this a terminal application scared you, like don't worry too much about that. I want to give you an example of an interaction that I had. So this was in agent mode. This was a couple months ago. I had a piece of, so this was a code base. This was a PHP code base, 10 or 15 years old or something like that. Lots of copy paste stuff. I found this one pattern that had been copy pasted a whole bunch of times all over the code base, and I wanted to consolidate it so that I could do some other refactoring to make the code better. Basically, I wanted to move. There was this piece of code that did this mapping, and it was in, I think it was in a repository class, and I wanted it to be in a domain object class because it felt more appropriate there. And then when it was in the repository class, then they had to make it public and static so that other people could use it and stuff. I just felt weird. So I'm like, okay, I want to do this refactoring. This is PHP. If you haven't worked in PHP, it is a dynamic language. You don't have compile time support. If I'd been doing this refactoring in language like C# that had compile time support, I would have like gone and made the change and then used the compiler to tell me where all the errors were. Right, that's a pretty standard pattern, but I can't do that in PHP. I would end up getting runtime errors instead. So I need to go and like manually find all the places. The tooling helps. It's pretty good, but it's not. It's like 98% maybe, and which does not make me feel comfortable enough. So I had to go through and find all the places. And when I first did the refactoring, I noticed this like one usage here. So I don't know how I did this in the tools. I missed the other 147 usages of this code. I don't know how I did that. I spaced it that day or something. And so I was at this point where I did this one refactor, and then I realized I needed to do it in 147 other places. And it's not just a automatic refactoring tool chain, extract method or, something easy. It was, I would have had to go and manually change all of these 147. So pre-AI dev tools, what I probably would have done, I probably would have said, no, that's too risky. I'm just going to back out this change. It would make the code a little bit better, but it's too much risk and too much effort right now to do. But with AI dev tools, I said, hey, go find all the instances of this. I did do a search to get a pretty good idea of all the instances of it. But it was a thing where I would have to actually manually change the code in each place, right? I couldn't do an automatic refactoring. So I kind of knew where all the places were probably, but I didn't want to go and manually change them all. If I were super great at regex find and replace, I totally could have done it with a regex find and replace. But I suck at regex find and replace. So I couldn't do that. So I went and asked, in this case, Copilot, I was like, hey, I need to do this refactoring. Here's an example of it, of where I already did it. Go do it in this directory. I think there are 45 instances of it. And it went and it did them all. And then I broke it up by folder. Maybe I didn't need to do that. I don't know. I was afraid that it would get confused, like it would run out of context space and stuff like that. So I broke it up. And then it did it. And so I did it, with a folder that had 45, and a folder that had 61, and a folder that had 20 or something. I can't remember what all the numbers were. And so I chunked it up, and it actually did a great job. And it, like I said, it ended up being a smarter find and replace. If I were better at regex find and replace, which I'm not, I could have done it, but I'm not good at that. But AI tools are good at doing regex find and replace. So this was a cool moment for me because there was this refactoring that I wanted to do. I got to a point where without these additional tools, I would have just said, no, I'm not going to make my code base better today, right? Which is a thing that I don't like to say. But having to go and do all those changes manually felt too risky. But because I had these AI dev tools, then I could go and do that refactor that otherwise would have felt too overwhelming. And I made my code base a little bit better. Were you gonna?
Yeah, I had a question.
Yeah.
So I can perfectly relate to not being great at regex. When like Claude or whatever you're using says, hey, I'm about to run this regex to find everywhere it is, do you like try to reverse engineer and figure out what that's doing versus just saying, yeah, go for it. Like, I'm not going to like figure out what you're doing for the regex. Let me see what the results are, see if the test passed.
I don't try to reverse engineer the regex because
Sure.
I'm not good enough at regex.
Sure.
But I will try to like look at which files it found and say, so look at it more from like the results perspective as opposed to the actual regex that it writes, because yeah, I suck at regex. If you learn nothing else from this presentation, you can learn that I suck at regex. Okay, another similar example. I was doing I wanted to code up Hunt the Wumpus. Anybody know? Anybody ever heard of Hunt the Wumpus? Anybody not heard of Hunt the Wumpus? Okay, this is like an old programming game. It's like mainframe sort of days. The idea is it originally started as a text game, and the idea is you would type you're in a maze, and every room is connected to 3 other rooms, and somewhere in this maze of rooms there's a wumpus, and if you go into the same room as the wumpus, then you die. But if you shoot an arrow into that room, then you'll kill the wumpus and you win the game. And sometimes, depending on the exact implementation, sometimes they're bats, sometimes they're treasures, sometimes they're pits, and other things like that. So it was a really early, text-based game that was relatively simple to implement. I wanted to implement it as like a web application, just show some architectural principles. So I just told, let's see, this one I think was also Copilot. I just told Copilot, hey, go write this for me, and I want you to do it in this language, and I want you to follow these architectural patterns, and I want the front end to be like this. And I tried to, as best I could, one-shot it. So if you're not familiar with that term, one-shot is where you just give a single prompt and you want to get the exact right answer from that one prompt from AI. Oftentimes that doesn't work, but that's what I was trying to do here. And so if you take in Hunt the Wumpus, because every room is connected to 3 other rooms, if you take all those rooms and like wrap them around together, it makes a dodecahedron, a 12-sided polyhedron, where each point on it is the room, and each of the sides are the connections between the rooms. When Copilot made the UI for my Hunt the Wumpus, it made it look like this. So the circles on the left are the rooms. The orange one, hopefully nobody is orange-green colorblind. If you are, I apologize. You can blame Copilot. The orange circle is the room that you're in, and the green ones are the ones that it's connected to. You can see at the bottom here, at the bottom it makes sense because I'm in room 18, and 17 and 19 are connected to it, right? And that's easily visible. But 9 is also connected to it, but it, like visually, you can only see it because it's green. They're not spatially close to each other. And this would have been fine, but I wanted to make it a little bit better so that it was more visually accurate, I guess. So that the rooms that were connected to each other were actually like physically close to each other. The circles were physically close to each other. So I did a search, and it turns out that if you take a dodecahedron and smash it down into 2 dimensions, you get what's called a dodecahedral polygon, I think is what it's called. And so I said, hey, Copilot, go take these rooms and make them into a dodecahedral polygon for me. And it was like, sure, I can do that. Actually, this was funny. A lot of times AI dev tools, they're like, well, AI tools in general, the current crop of them, are very like positive of like, oh yeah, sure, let me do that for you. Look, I did such a great job. Or, they're very positive. When I did this one, I was like, okay, go do a dodecahedral polygon and lay the rooms out this way. It was like, I will do that. Like, oh, okay, you'll do it. But you're not super happy about it. Okay, anyway, but it did it, and it didn't actually get it right, but it got it close. So it laid this is after I took what it did and changed some things. So it laid all the rooms out in the right place, but it didn't get the connections quite right. So like you can see there are 3 concentric pentagons, right? There's the big one, and then there's the little one, and there's the tiny one in the middle that's upside down. It basically like rotated them, and so all the connections were weird, but it got all the rooms in the right place. And so with that, I was able to like go and look at the code and change. I tried to get it to rotate it correctly and get it to lay them out right. It just couldn't do it. But I could go into the code and see what it was doing and adjust it a little bit, and then actually get it to lay out the way that I wanted it to. So I thought this was another great example. Like it would have been fine especially for what I was doing. Like the fact that how the rooms were laid out in the UI wasn't really important to my purpose. My purposes for this were to show some like back-end architectural patterns. And so if I had just left it with this UI, it would have been fine, right? But because I had these AI dev tools, I could do this thing that I wanted to do, but doing it by myself, there was the barrier to entry was too high, right? I wouldn't have actually done it myself. But because I had these AI tools, in this case, it didn't actually solve the whole problem, but it got close enough. It reduced that barrier to entry for me, right? So this is another example of I could do something that I wanted to do, but that I probably wouldn't have done before. So I thought that was cool. Let's talk for a minute about legacy code. Who loves legacy code? Anybody? Yeah, legacy code's the best, right? So by legacy code, of course, we mean old code that nobody wants to work on, that's ugly and gnarly, right? Has anybody ever read this book before, Working Effectively with Legacy Code? Anybody read this? Oh man, I should get like a Amazon affiliate link for this book. I pitch this book so much. If you haven't gone and read this code and you ever work with legacy code, go buy this book. Has anyone ever had that sinking feeling where it's like, oh, I have to go look in that code. I have to go change something in that code. And it's horrible and terrible and scary, and you hate your life because you have to go look. Anybody ever been in that situation before? Yeah, a few people. Okay. If you've ever been in that situation, especially if you're in that situation now, go buy this book. Because it's all about how to take that code that's horrible and terrible and slowly over time make it better. And the solution is to make it slowly better over time with tests. And so the whole book is like just a bunch of patterns of how to safely change this bad code to make it slightly more testable, so you can put tests around it, so that then you can have more confidence to make more significant changes and get more tests and then have more confidence. And anyway, it's like this virtuous cycle. But the way the process oftentimes starts is, you have this big chunk of code and you can't change any one part of it without changing everything. Excuse me. But you want to like start breaking it up and, extracting things, or, modularizing it or whatever, introducing abstractions. But you want to make sure you don't break the whole thing. So in Working Effectively with Legacy Code, what the author, Mike Feathers, he suggests is that you start with one like big test, one or maybe small number of big tests that kind of test the whole thing. You're not going to test every single path in this giant block of ugly, nasty code, but you're going to get sort of like a happy path, right? To make sure that when you go and make your next change, that you don't completely and horribly break everything, right? Maybe you might have something that gets broken, but you're not going to horribly break everything. And he calls that big initial test, he calls it a vice test. So think of it like a vice on a workbench, where you're going to hold this thing that you're working on in place so that it doesn't slip wildly and shoot up into the ceiling of your workshop or whatever, right? Turns out that so writing these vice tests can be super valuable, but it can also be pretty hard, because you have this code that wasn't designed to be tested, and you're starting to get it under test, and sometimes you have to pass in a bunch of different parameters, and you have to like construct objects that get passed in as parameters. You don't know how to do that. Excuse me. Otter. And so it can be kind of fun. It can be kind of a fun puzzle to figure out how to do that, but it can also take a lot of time. Turns out AI can sometimes do that really fast. And so it can get that initial test in place a lot easier than you can sometimes. I was working on a piece of code. This was a couple of months ago. This was that same PHP code base. And there was this big piece of code that had no tests on it, had never been tested. I wanted to get one of these Vice tests in place. So I asked, in this case, again, it was Copilot, asked that, and it thought like for several minutes about it. And it went through its whole thought process. It's fun when you like look through the thought process on some of these, like, oh, I see, I'm going to do it this way. And then later it changes its mind. Oh, no, let me think about that differently. That was a bad approach. Let me try this other thing. That can be kind of fun. And then it's like, oh, let me revert my changes and do something simpler. It generated a whole bunch of code like this. Unfortunately, in this particular case, the test didn't actually work. But it did get close. I can't remember if I changed it on, if I went and manually made it so that it worked on this one. I think I did. I don't remember. But in this case, it didn't actually work. That initial Vice test didn't actually work, but sometimes it does. So like if you're in that situation where you need to get some piece of code under test, maybe your AI dev tool will help you. Code reviews, we were talking about this just a little bit beforehand. When I first gave this presentation, I gave it like on a Saturday, and that week at work, we had turned on the Copilot code reviews on a couple of our repos at work. And I was the one who actually went and turned them on. And when I did, I was like, I am only turning this on this one repo because this is going to be stupid. It's going to come up with all these like stupid nitpicky things, and it's just going to be noise, and we're all going to hate it, and then we're going to turn it off. On that, I can't remember if it was Thursday or Friday before the first time when I gave this presentation, I was refactoring some code. There was this, again, it was copy paste was the preferred design pattern there. And so we had this pattern in the code that was copy pasted, I don't know, 20 different places throughout the code. I was like, this is terrible. Let me just consolidate these all into one. And so I did this refactoring where I found all the 20 places and consolidated it into one. And I created a PR for it. And Copilot ran. And it said, hey, in this one place where you consolidated this functionality, this method that said that you extracted out, it said it was only doing one thing, but in this one place, it was actually doing two things. And you lost the second thing because of your refactor. Because I read the name of the method that said it was doing one thing, and I foolishly assumed that it was doing one thing. It's really doing two things. And Copilot caught that one. It actually saved me from, breaking code, which is cool. So again, that was on Thursday or Friday, the Saturday before I first gave this presentation. So I'm like, well, better put that one in. That seems relevant. So there are other tools. So this was Copilot code reviews. There are a lot of other tools. Where I work now, we use one called Code Rabbit. It's a lot more chatty. I don't know if it's because our code is worse, but it's a lot more chatty than the Copilot ones were. So I don't know how I feel about that yet. Oh, is this code testable? Oh, yeah. This one was fun. This one was a little bit more recent. This was just this week. Yesterday? No. Maybe Tuesday. I don't remember. It was earlier this week. One of my coworkers, one of the people on my team, he was doing some. This was in C# code. We had some containers that when you deployed them, we would get a big spike of errors. Not a big spike, but we get a spike of errors. And it was because we had some like background processes or whatever that weren't terminating correctly, and so we would eventually like just kill the container that they're running in, and we get some errors from it, and then the new container would spit out. So it wasn't like wasn't actually broken, but it made our monitoring ugly, right? Because every time we deploy, we'd get a spike of errors that weren't really errors. And so he went and figured out what the problem was. I think he just had Claude do it. It ended up being like a cancellation token thing. We weren't handling that right. And he created a PR for it. And, he asked for people to review it. And he changed 2 files. And I looked at the one and I was like, I think, he had some stuff dependency injected into it. I was like, I think you could probably write some tests for that. But he didn't have, in his PR, there were no tests, and there were no test changes. So I'm like, oh, this is probably one of those places in our code where the code could be tested, but we just haven't historically written tests. And so I was going to ask him about it, but he was busy with something else. So I just pulled the branch locally and asked Claude, hey, Claude, is this code, are there any tests for this code? Are there any existing tests? I was expecting to say no. And that's why he hadn't changed any of the tests. So I said, hey, check to see if there are any tests. And Claude came back and was like, oh yeah, there are tests for this class. I was like, oh, that's kind of surprising. And so I said, do the current tests cover the functionality that was changed in this PR? And Claude looked at it and was like, oh yes, these existing tests totally cover the functionality that was changed in this PR. So then I said, remember, there were only 2 files changed in this PR, and none of them were test files. So I said, if the existing tests cover this code, how come we didn't have to change? How come no tests were changed? Like, if we change the functionality and there's tests that test that functionality, we should have to change the tests so that they all still pass, right? And Claude was being clever and said, that's a sharp observation. The tests don't actually cover the new behavior. So it looked at the tests and, again, it thought about it really hard and decided that they did cover the functionality, but they didn't really, right? And so then I got a little snarky and I said, it was like, oh, do you want me to add those tests? And I said, yes, add those tests. And I explicitly said, make sure the tests fail if the changes from the PR are not in place. Like I wanted to do the whole like red-green, in this case, not refactor, but I wanted to do sort of its typical TDD cycle. So write a test, take out the changes from PR, make sure the test actually test the thing that was broken, then put the changes back in, then make sure all the tests pass. And I got really snarky at the end. I'm like, actually do TDD. It didn't, fortunately for to Claude's credit, it did not get crabby back at me. I was expecting it to get a little snarky, but it did not, and it actually did the thing that I told you. It took the changes out, wrote some tests, made sure that those tests failed, made sure that they failed for the right reason. Initially, they didn't. So that was great. But anyway, and then it did this whole cycle, and then that change then had tests that actually tested that change. Because it felt important to me because stuff like cancellation tokens are really easy to get wrong. And if we finally got it right, let's make sure that we keep it right. But, again, this is one of those, like, it's useful but not magical. Like it could go and add these tests, but initially it thought it didn't need to. And I needed to follow up and do a little bit more critical thinking to say, no, I think you do. I needed to push back on it a little bit. What am I doing on time? 7:14.
What time does this go till?
Oh yeah. When do we go till?
Rob, do you hold off hand? Typically,
Somewhere between 7 and 8:30.
Oh yeah.
Somewhere between 7 and 8:30. Okay. All right.
Well, I've got a jet, you guys, but thank you so much. This has been really good.
Yeah, you're welcome. We'll talk about this one. Yeah.
Can I ask a question while we're...
Yeah, sure.
On that last example,
This one that got messy.
in
Yeah.
each of your prompts, how long does it take Claude to respond for you?
Let's
Was it like 10 seconds, 30 seconds, a minute,
let's see if it is on here. Sometimes it has like the time. I was just gonna see if it had the time.
Yeah, like noodle for 20 seconds or whatever.
Yeah, I don't think this one has the times on it, but it wasn't super long. It was something on the order of seconds, like
Okay.
tens of seconds.
Right? There's a whole, you sit there and wait, or do you context switch to something else?
Yeah, that is a great question. That is a great question. Do I have a thing about that at the end? I can't remember if I have a thing about that at the end. If I don't, we'll talk about that at the end. Okay. But yeah, so this particular one, because I was looking at a single file, it could like go, it did a, when it went to search for test, it, basically searched for that file name tests or whatever. And so,
quick, but besides searching, sometimes it's like,
yeah. Yeah, probably the initial one was longer because, well, I don't know. Maybe not. I can't remember. It was not long enough for me to be like, I need to go take a bathroom break or something like that. It wasn't that long. So, yeah. So in this particular case, I did not context switch. I wanted to talk about this one really briefly. Again, this is a more recent example. At the job where I work now, we use RabbitMQ. Anybody use RabbitMQ before? Generally, I like RabbitMQ, but the way we use it, I do not. It's horrible. We had two different code bases. One was in JavaScript, one was in C#, and they both did this weird thing where they would, if you they processed a message off of Rabbit. If they failed to process it, they would put it into this like shared queue between everything, and then it would automatically get re-queued back in the original queue after some timeout. And so I think the JavaScript one would keep track of how many times it had processed that message, and would eventually, if it processed it like 3 times, eventually it would just throw the message away if it failed too many times, which is super awesome, right? You always love losing data. The C# one would just keep processing it forever, so we would have messages that would just keep getting reprocessed for days and weeks. That was super cool. If we had messages whose processing got into an infinite loop, they would also just keep getting reprocessed forever, and eventually it would eat up all of our like consumer Docker containers, and then they would all crash, and then we wouldn't process any messages, and we'd have to go manually find that one. And anyway, all kinds of great things. And it caused an outage one day. And so we were finally like, all right, this is stupid. Let's go fix this. But this was something that was very central to how our whole application works, how it processes messages and how it requeues them and stuff like that. This was non-trivial functionality. That was cool. Which, so we were going to go and change this and actually do actual dead letter queues per queue and do processing timeouts and things like that. All these kinds of good things. And we were going to make it so that the JavaScript version and the C# version actually did the same behavior instead of almost the same behavior, but slightly different. You can never remember which one is which. And I didn't do the main part of the code. Someone else had Claude go and look at both implementations and come up with a plan on how to change them on I think we added tests on both sides. We refactored the C# code so that it was more testable, so that there were parts of it that couldn't have been tested before that were testable. And spoiler alert, we worked on it for a couple of days, and we deployed both the JavaScript version and the C# version, and they just worked, and they handled messages properly, and they didn't end up in infinite loops, and they didn't end up timing out and killing our Rabbit connections and all these horrible things that we did before. Which again, without AI dev tools, that's something that would have terrified me before. It still scared me. But I don't know that I would have done that before, because it felt like it was too high risk. And that's why no one had done it before, because it was too high risk. But with these AI dev tools, we were able to do it. Now, one thing that we did notice after the fact, you'll know, so this is the PR. This is one of the files. This is one of the, this is the C# code base. You can see in this file, there were a lot of changes. In the whole PR, just on the C# side, we ended up with 59 file changes, which is kind of a lot. In this particular file, we added 130 lines and deleted almost 150. I don't remember how long the actual file was. So it ended up being quite a large change. We realized after the fact, though, that we without actively choosing to do so, we solved multiple problems at the same time. So there was the problem we actually wanted to solve was, instead of putting all the messages onto this shared queue that automatically requeued stuff, the main problem we really wanted to do was just, when messages failed too many times, we wanted to put them on a dead letter queue, a separate dead letter queue per processing queue. That was our original problem that we were trying to solve. When we were there, without explicitly deciding to do so, we also fixed, like, there was a problem with correlation IDs that weren't getting populated, so we fixed that. And I mentioned the messages getting processed infinitely. We fixed that, and being processed in infinite loops. We fixed. So we ended up fixing a lot of stuff, and that's part of why this PR got bigger than I would have liked it to. So that was the thing that we learned from that, is that because it was easy to make these changes, and we were already in there, we made more than we really meant to. They all ended up being good changes, and they all ended up working. So in this particular case, it worked out well for us. But it was a thing that we learned, that it was easy to make our batch size too big, bigger than we wanted it to be, right? The last example that I want to talk about, this is what I was doing today and yesterday. So in our system, we have the ability for customers to upload files, mostly pictures, but other types of files too. And we have 3 APIs that they can use to do this. There's one in JavaScript, and it's mostly full-featured, but it has lots of inherent problems like race conditions, and it allows, basically, we use Elasticsearch to look up these files, and we, for reasons that are beyond fathoming, we allow users to basically pass in raw Elasticsearch queries into these endpoints. So, yay for SQL injection attacks, but I mean, it's not SQL, but so we have a JavaScript API, then we have an attempted rewrite that only provides like a third of the functionality, and also does it wrong. And then we had another rewrite that does most of the functionality, but for half of it, it just calls back to the JavaScript API, and the half of the functionality it provides it does well, but the other half it just passes through. Anyway, so like we have these 3 different APIs. They're in 3 different code bases. So you have 3 different APIs, 3 different code bases: JavaScript, C# and C#. Different versions of C#, of course, because you wouldn't want them to be the same. That'd make it too easy. We have 11 different internal consumers. So that's across different front-end applications, our Android application, our iOS application. They're all calling different combinations of these 3 APIs. Some of them only call 1, some of them call 2, some of them call 3. Some of them call 1, the third one, but not the first one. Anyway, and so let's see. Do I want to? Yeah, I'll go here. So as you can imagine, this also doesn't include in that some of our external customers call these APIs, but we're not going to worry about that right now. So as you can imagine, like figuring out, we want to make this one API that actually does all the right things, that doesn't have concurrency problems, that doesn't have SQL injection problems. But we need to figure out what are all the APIs that we're providing now, and how are all of our different consumers using them. You can imagine that doing all of that investigation manually would take a really long time, right? Going and finding all the places that you need to look at, much less actually looking at them and figuring out what they're doing. I don't know, maybe you guys are faster than me. I would expect that if I were to do that manually, I would expect that to take days or weeks, maybe months. right? To like catalog all of that and figure it all out and understand how it all works. This week, I was having Claude Code. So what I did is I pulled down like, I don't know, 50 of our repos or something. And I said, hey, I want to figure out how this files API works. I'm pretty sure there's stuff for it for the actual endpoints in this repo, this repo, this repo. Go figure out what all the endpoints are, what we're what they're accepting, what we're returning back from them, and also go find all the consumers that you can of them. And Claude actually did a pretty good job of like going across all these different repo, so it had to look across. I mean, some of the initial searches were probably, just like a command line ls or something like that. Some of the initial ones. So it probably cut it what it searched down a lot from that initially. But it was able to search across all these different repos and keep enough context to remember what it was doing. I think I only used up like 40% of my context window or something like that. And so then it was able to like make this whole report for me of like, here's every single endpoint. This one comes from the JavaScript code base. This one comes from the old .NET code base. This one comes from the new .NET code base. Here are all the consumers of each endpoint. It's not in this document, but it's in another one. It had here are all the fields that each of the consumers of each of the different endpoints use and stuff like that. I haven't gone to go and actually change the code yet to see how accurate it was. So I might have some good learnings there. But I was really impressed that it was able to do, because I don't know, 6 months, a year ago or something like that, it felt to me at least anyway, when I would ask AI tools to do stuff, it was like, well, if you could look through this whole file that's a few hundred lines long, like I'm pushing it, right? But the progress that they've been making just in the last 6 or 12 months or something, I can now search across thousands of files to get a way better view of my system in way less time than I've ever been able to before. So I did this to generate that particular chart. I don't have the prompt that I wrote, but you can see it took me 6 minutes and 45 seconds. Where, like I said, doing that manually, I would expect that to take days or weeks or months. So that's pretty cool, right? Oh yeah, 6 minutes 45 seconds. Okay, so those are some examples of some things, some ways that I've used some of these AI dev tools. There's lots more that maybe you have used that I haven't. So I talked a lot. What can we take away from all of this? There are a few things that I think could be valuable to take away from this, both from this like software craftsmanship perspective of looking at AI tools and some of these experiences that I've had. The first one being that things are changing very rapidly. So if you feel like you are not up on all of the latest AI dev tools, welcome to the group. I don't think anyone is. So don't feel bad if that's how you feel. If you don't know what the absolute best way to use these tools is, welcome to the group. I think that's the rest of us too. There isn't really a best AI dev tool right now. I did add, this is in preparing for today, I had to go through these slides and change a bunch of stuff from the first time that I gave it. So I put mostly here, right now, if someone came to me and was like, hey, what AI dev tool should I use? A few months ago, I would have been like, just pick one. They're all about the same, it's fine. Right now I'd say, go do Claude Code. Go do Claude Code. It's kind of I don't know that it's the best, but it's there's a lot of standardization around it and stuff like that. So if you're not using that one and you're using some other tool, you could probably use the models that Claude Code uses anyway. So it's probably fine. But if you're going to start from scratch today. That's what I would recommend. There with these AI dev tools, there are definitely some wins. Like I talked to some in the examples that I showed, and I'm sure a lot of you have had your own examples. There are some places where you can like get these big wins, right? Like you can do a lot of work or write a lot of code, and you can do it really fast, way faster than we've been able to do in the past. But there are also some times when it can go really wrong too, right? Like it can make assumptions, or it can tell you stuff very authoritatively that's wrong. And so you have to be aware, right? I think that's a good thing to remember. One of the takeaways for me, at least anyway, is that I gave a couple examples of this. These AI dev tools, for me, have been letting me do things that I kind of wanted to do, but the barrier to entry was too high beforehand, right? Like the hunt the wumpus thing, you know, some of the other things. It's like, oh, I'd like to do this, but if I were writing the code myself, I'm going to put my time and effort into something more valuable. But it's still this thing that I want, and AI dev tools have been letting me get some of that other stuff that I want that I just don't have the time and energy to actually do, because Claude does have the time and energy to do it. This one is providing the appropriate context can be super important, though this is less important than it used to be. Like, as I mentioned, you know, even like a year ago or something like that, making sure that the context you were providing was really important. You know, not giving too much context. You know, just look at this file and this file, or only this part of this file. Like that seemed a lot more important. And now I can go say, hey, go look at these 50 repos and just figure out what's important and let me know. So this one's maybe less important than it used to be. I do think this quote is still very relevant. I went to a GitHub Copilot training presentation thing a few months ago, and it was like I think it was the what do they call them in Microsoft, program managers of GitHub Copilot, but they only said his name at the very beginning of the presentation, and they never said his name once ever again. My name's John, by the way, in case you missed that. Anyway, so I don't know what his name is, but he said a great quote. You know, so this is the guy in charge of GitHub Copilot. He literally said, "Always review AI-generated code." You know, the whole presentation was on how to get Copilot to generate code for you, but one of his takeaways was, always review AI-generated code. One of the things that I think is, so with these AI dev tools, it's been making me question some of the specific practices that I have gotten value from in the past. Like exactly how my code looks, like the exact formatting or things like that. Maybe that's not as important as it used to be. But I think there are a lot of underlying principles behind some of the practices that we've gotten value from in the past that do still provide us value. Some of those things like fast feedback loops and easy to maintain code, though I'm not sure exactly what that means for Claude these days. Like what exactly is maintainable code for Claude? I don't know exactly what that means. But I think it is still important for it to be able to change my code. Working in small batches. We were going to talk about batches. It's really easy to, because it's easier to change code and change a lot of code quickly, it's easier to get a larger batch than you mean to, like in the example of that one PR that grew. I think, let's see, I think I do have, well, somewhere I have another one. It's also, I think I have this one later, but we'll skip to it now. It's also super easy to, because Claude is over here working for 5 or 10 minutes or something on something, it's really easy to say, oh, well, I'll just go start another Claude instance. I'm going to start something else. That one's working for 5 minutes. I'm going to go start another Claude instance. That one's going to be working for 5 minutes. Let me go start a fourth one, you know, and it's really easy to get a lot of work in process. In the past, limiting my work in process has been something that I've gotten a lot of value from. Like in the past, I've tried really hard not to like context switch between a bunch of different projects or a bunch of different work items or something like that. I don't know if that applies exactly the same with a bunch of if I'm babysitting a bunch of agents, but I think if I have I know in working with some coworkers on some of the things that I mentioned recently, I know that when we get like 6 different conversations going on, when we come back to the first one, we don't remember what's going on. And in the situation we were doing anyway, maybe in your situation, that's not the right number, but I think there is a number where doing too many things at once is probably not effective anymore. I don't know what that number is, but don't stop working with real people. I've been doing like a lot of Claude code recently. Like it's been writing all the code. I haven't been writing any code. But I still get a lot of value out of working with real people, like talking through the ideas. Hey, I came up with Claude and I worked together and we came up with this plan of how we should implement this feature. What do you think, real person who actually has the context and knows the system? Like those interactions are still provide a lot of value. So like, I get kind of annoyed when people call, Claude Code a pair programming tool. I'm like, have you ever actually pair programmed before? Because this is not the relationship that I've had. Here's the limiting work in process one. I talked about that they're probably, I don't know if it's the same number of things in process as it is with agents as it is with just me, but I think there is a number where like you can work on too many things at once, and you have to pay too much context switching costs. For me, it kind of like a lot of it just goes back to, even though I may not be typing all the characters for the code, it's still my responsibility to make sure that the code actually works, that it actually does what I think it should do, that it is actually going to provide value for my users, that it's not going to crash, that it's not going to corrupt my data or delete my production database or anything. Like that's still, even if I'm not the one typing the characters, that's still ultimately my responsibility. I can't give that responsibility to Copilot or to Claude or to whoever. Same kind of thing, making sure that my code is still maintainable, that I can change it later, not just that I can change it, but that I can change it with confidence, that I can add new features or fix things and know that my code still works. Through whatever mechanism that is, that it feels to me like that is still my responsibility. I can tell the agents how to do that. They can write a lot of that code for me, but it's still my responsibility to make sure that this is true. And so some people have taken this opportunity. You see the like vibe coding bro posts on X/Twitter of like, hey, I vibe coded this awesome thing over the weekend and coders are obsolete, blah, 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 blah. Then you see the follow-up tweet where it's like, oh, hey, I'm getting hacked. How can anybody help me? Some people take this as these new tools as an opportunity to say, oh, well, I don't have to care about my code as much, right? But I think the opposite is true. We have an opportunity to care more about our code now because we don't have to spend as much time typing, right? And so we have more time to think about what our code actually does. Think about if it's correct. Think about if it's providing value to our users, if it's doing the things that we think that it should be doing. So, yeah, that's it. Hopefully some of those experiences were useful. Hopefully some of the perspective of how thinking about how AI dev tools can relate or not to some software craftsmanship ideas was interesting too. And yeah, that's it.